All right, so we're going to talk about three different things today. We're going to talk about, excuse me, zeros of a function. This is going to come back over and over and over and over again. We're also going to talk about rate of change. It's basically the same as slope, but you can only find slope in a linear function because it's constant. And any other time you have to find how much a point is changing from one to the next, you have to use rate of change. And then we're going to talk about if something is odd, even, or neither, graphically and algebraically. So the first thing I want to remind you, if you guys don't remember, what zeros of a function mean. Zeros of a function, another way we can call them are x-intercepts. That's where the graph crosses the x-axis, right? Zeros of a function are also called solutions. So we have zeros, x-intercepts, solutions, or roots. All of those things mean the same thing. If you have directions and it says find the solutions, that means x-intercepts. If it says find the roots, that means x-intercepts. If it says the zeros, that means x-intercepts. Okay, and the way that we find those is everyone's favorite. What do you have to do? You have to factor. All right, factoring is never going away. Even when we get to trig stuff, you guys have to use factoring. So if you're not good at factoring, we have to get good. We're going to just practice, guys. It's all the factoring that you've seen before. You have to talk about GCF, factoring a trinomial where A is 1, where A is not 1, and grouping. When we group, that you have 4 terms, right? And then sometimes factoring won't work, and we'll get to that later on in chapter 2, and we have different methods to use. But when you're factoring, we're going to go over some problems. When you're factoring, the first thing you ask yourself is there a GCF? Then you say, okay, is this the difference of perfect squares? Is this a trinomial that I could break into 2 binomials, or is this grouping? Everybody with me? Right here, this statement says, the zeros are a function are the x values for which f of x equals 0. What's another way of saying f of x equals 0? Where y equals 0. Okay, good. All right, that's just what that's saying. Okay, so let's factor these. Now, I might factor a trinomial differently than you do. And that's okay. That's totally fine. But if you're going to find the zeros, what you're going to do is it's where f of x, which is y, equals 0. So we're going to replace the f of x, and I'm going to say 3x squared plus x minus 10 equals 0. Can you have the 0 on the left-hand side? Absolutely. I just don't like it over there. Now, do you guys agree with me? This is a trinomial. There's 3 terms. Okay, so first thing you look for is GCF. Is there a number that all 3 of these have in common? No. All right, so now we have to factor the trinomial. See if we can factor it. I like to take a times c. A times c is negative 30, yes? 3 times negative 10. So negative 30. And this is the way that I factor a trinomial where a is not 1. If you do it a different way, do it your way. It's fine. But I say, what are the factors of negative 30 that multiply to give me negative 30, but add to give me 1? What would it be? 6 and 5. Okay, what kind of 6, what kind of 5? Positive 6, negative 5. You guys agree? Now, the step that is different that I do that some other teachers don't is I take the a term, God bless you, or no? Was that a cough? My bad. Well, when you sneeze, hang on to that. I'm going to take my a term and I'm going to divide both of my factors by my a term. Again, if you don't do this to factor your trinomial where a is not 1, that's fine. All right, I have my x's in the front of my parentheses. Now I say, does 6 divided by 3 reduce to a nice pretty whole number? Yes, so this is x plus 2. Does negative 5 divided by 3 reduce to a nice pretty whole number? No, so my 3 is going to become the coefficient of this parenthesis. All right, that'll work every time. If you guys don't like it, don't worry about it. If you're like, hey, I kind of like it, but I don't get it, we can go over it a little bit tomorrow. I can give you guys some extra practice. But now if you're going to find the solutions, guys, you're going to find the roots, you're going to find the intercepts, what do I do with those 2 parentheses? You set them equal to 0. Perfect. So I'm going to subtract 2 from both sides here. So x equals negative 2. Here I'm going to add 5. And then divide by 3, correct? So where does this parabola. I know it's a parabola because it's squared. Where does it cross the x-axis? At -2 and at +5/3. So you just found the zeros of the function. You found the solutions, the roots, the x-intercepts. Questions? All right, 90% of the time when we have you find the solutions, it's going to be a factoring problem. But you might see it another 2 different ways, so I'll just show you. All right, finding the zeros. What does that mean? G of x, is that the same thing as f of x? H of t, is that the same thing of f of x? Yes, that just means, cross this out, make it 0. So I have the square root of 10 minus x squared equals 0. Don't forget your algebra skills, guys. Everything under that expression is stuck under that expression of the square root until you get that square root to go away. How do you get a square root to go away? You square it. If I square this side, what you do to one side of an equation, you do where? To the other. Perfect. When you square a square root, what happens? It cancels. So you have 10 minus x squared equals 0 squared is 0. Yeah? All right. Now what? Okay, tell me. Well, 0 squared is what? Just going to be 0. You're fine. Now, you could subtract 10. That's what I would do because I like variables on the left-hand side. But some of you are going to say, can I just add x squared? Yeah, you can. But I like my letters on the left. Very particular about that. I don't know why. So I'm going to subtract 10 from both sides. So negative x squared equals negative 10. Before I can take the square root, what do I need to do? Divide by -1. Perfect. So you have x squared equals 10. There's a step here that you guys, some of you are going to forget, and you're going to get points off for forgetting this point. What do I do now? I take the square root. Guys, when you physically put the square root on top of a number, what goes in front of your answer? Very good. Plus or minus the square root of 10. If you could break down the square root of 10, yes, this one doesn't. But understand, this graph crosses the x-axis in 2 places, at positive root 10 and at negative root 10. Whenever you physically put the square root on top, you have to put that plus or minus in front. Anytime you take an even root, if it was the 4th root, you would have to say plus or minus. If it was the 6th root, you'd have to say plus or minus. Everybody with me? Alrighty, scooting along. All right, again, h of t, that's just function notation. That's just saying, okay, and I'm going to change my t's to x's because they'll turn into a number in the middle of the problem. So I'm going to say 2x minus 3 equals x plus 5. Sorry, over x plus 5 equals 0. Could I write 0 over 1? Is that all right? Any whole number you could put over 1, you're fine. I like to do that because when I have a denominator on one side, I like to have the other side to have a denominator. Because when you have a fraction equal to a fraction, what can you do? We can cross multiply, yep. So this becomes, what? 2x minus 3 times 1 is just 2x minus 3, right? Equals, what's x plus 5 times 0? Very good. So now what do we do to both sides? Add 3, perfect. 2x equals 3, we divide by 2, and x equals 3 over 2. Now guys, what is the beauty? What is the beauty of having x equals an answer? What can you do with that every single time you have a problem? You can plug it back in. All right, am I going to make you guys check stuff? No. But if you have an extra minute, anytime we're doing factoring and finding zeros and solutions, if you have an extra minute, I would plug your answers back in to see if you get your original problem. It's helpful. All right, so when we find the zeros, what you guys are doing is setting the equation equal to 0. Your f of x, your y becomes 0, and you solve. 90% of the time stuff we do, it's going to be factoring. So we're going to practice that. All right, now we're going to talk about rate of change, the average rate of change. Now, the reason that this is different, guys, from slope is because in slope, from this point to this point is the same as this point to this point, which is the same as this point to this point. You guys agree with me? It's constant. When you are talking about rate of change in a function that is not linear, the distance from this point, not the distance, I'm sorry, the value from there to there is going to be different from there to there. It's just the way that math works because it's not a straight line. But what I want you to see about the rate of change formula, this is the rate of change formula. Have you guys seen that before? Yes. It's the slope formula, but you don't say, oh, this is the slope, because slope only applies to a linear function. So this is the rate of change. So the way that this question will be presented to you on your test, on maybe an SAT question, is they're going to give you a function. Do you see how they gave you this function? F of x equals x cubed minus 3x, yeah? Then they're going to give you two x values. They're going to say, what is the average rate of change between this x value, x sub 1, they told me negative 2, and then this one, negative 1. So all you guys are going to do is the slope formula 2 times, because f of x is a fancy way of saying what again? Y. So if I take the x value that they give me and I plug it into that equation, what variable am I getting out? The y. So all you're going to do in a question like this is say, oh, okay, I'm just going to take the x values they give me, and I'm going to plug it into this equation. So I'm going to say negative 2 cubed minus 3 times negative 2. What's negative 2 cubed? 2 times 2 is 4 times 2 is, so negative 8. And then negative 3 and negative 2 is plus 6, right? So negative 8 plus 6 is negative 2. So when my x value is negative 2, my y value is negative 2. You guys see that? Okay, I have a point. Now I'm going to plug in negative 1. I'm going to say, okay, negative 1 cubed minus 3 times negative 1. Well, what's negative 1 cubed? Negative 1 plus 3 gives me what? 2. Okay, so then I have this. I have negative 1 comma 2. Now, what do you think I do with these 2 points? I use the formula. They're going to give you an equation. You plug in the x values that they give you to find the y, and then you throw that in the rate of change formula. Now, again, because my brain works funny, I'm going to write them on top of each other, just so I don't make a silly mistake. This is my x, this is my y. Going through quizzes, some of you put x's on top and y's on the bottom. That's not the formula. I'm going to say negative 2 minus 2. Then I'm going to say what? Negative 2 minus a negative 1. You guys agree? So negative 4 over negative 1 gives me negative 4. So the average rate of change between the point negative 2, 2 and negative 1, 2 is what kind of 4? Yeah, I meant to put that. It's positive 4, correct? You guys agree? Now look at this. Look at this part of the graph. From here to here, if I were to follow the graph, is it going upwards or downwards? Is it increasing or decreasing? It's up. So does it make sense that your average rate of change would be positive? Yes. Yes, sir.
How do you determine what's from the 2 points determine what's x2?
It doesn't matter. Since I started with this y on the numerator, then I had to start with this x in the denominator. If you would have started with this 2 here, so 2 minus a negative 2, right? Then you would have had to say negative 1 minus a negative 2. So you would have gotten 4 over 1, same thing. Just whatever y you start with in the numerator, you have to start with that corresponding x. So guys, if they ask you for the rate of change now between this point here, or they did 0, right? Between 0 and 1. Should your rate of change be positive or negative? Why? You're right. Why? Because it's going down. Good. So what would you do? Well, you would plug in 0 for x, then you plug in 1 for x, and then you find the rate of change, which is the slope formula between those 2 points. Does that make sense? So, I mean, very basic on a test. I'll just give you an equation. Say, what's the average rate of change between this and this? Take the x values, plug them in, get a y, and then use the rate of change formula, which is also the slope formula. Make sense?
Okay, so on the quiz, like for A, like that question, you would just write 4, or would you write those 2 points?
No, they want the average rate of change, so it would just be 4.
4, okay.
You'd have to do all that work to find the points. All right, how many of you remember talking about, maybe not remember exactly what it is, but remember talking about even and odd functions? Algebra 2 honors you should have. All right, if we don't really remember, that's okay. We're going to talk about even and odd functions in 2 ways. It's the last thing you have to do. We're going to talk about it graphically, and we're going to talk about it algebraically. All right, algebraically first. You're going to test for even and odd. This is how they tell you to do it. I'm going to show you a way that I think is easier. But algebraically, you're going to plug in either an x or a negative x and see what your result is in your equation. If it's the same answer, then it's an even function. If it's an opposite answer, it's an odd function. Let's talk about graphically. Let's write things down. And this will make a little more sense. If you graphically are asked, is this function odd or even? Right? A function is even if both of these things happen. The arrows go in the same direction and the graph is symmetric. Symmetric, 2 M's, to the y-axis. What does that mean? The y-axis does what to the graph? Cuts it in half. It has to be perfectly symmetric to the y-axis, meaning the y-axis cuts it in half. A function is odd graphically if the arrows go in opposite directions and it's symmetric to the origin. What does that mean? All it means is it goes through the origin. So in order for a function to be even graphically, you're going to see a picture and it's going to say, is this odd, even, or neither? If it's even, both of the arrows have to be going in the same direction and the y-axis has to cut it in half. If it's odd, the arrows are going in opposite directions and it has to be symmetric to the origin, meaning it goes through the origin. That's what that means. So we're going to talk about graphically in a second, but now I'm going to show you algebraically. And you're going to use the same concept, and I want you to really remember these 2 words here. Same for even and opposite for odd. All right, algebraically, that's going to be the biggest thing for you guys to remember. Now, on your test, when you guys do this, and this won't be the only time you see it, you have to show your work. You cannot just write, oh, it's odd. You have to prove to me why it's odd or why it's even or why it's neither. Everybody got this written down? Oh, wait a second. All right, so here's a question, and it's going to say, here's a function. Is this odd or even? Guys, do not write down the first part that I do. I mean, if you want to, you can. But this is how the book would explain for you to do it. It would say, here is my function. G of x equals x cubed minus x. Now, before you start any algebra stuff, all right, we look at the highest exponent. What is the highest exponent in this equation? 3. So I say 3. Is 3 an odd number or an even number? It's odd. So there's only 2 possibilities that this could be. It could either be odd or neither. It can't be even because the highest exponent is an odd number. So what you would do is you would say, okay, if I plug in a negative x, what's the opposite of positive x? Negative x, right? So if I say, okay, negative x cubed minus a negative x. So this becomes what? Negative x plus x? If your function is odd, these two expressions will be, whoops, this should be cubed, right? They will be opposite of each other. X cubed, negative x cubed. Negative x, positive x. Yeah, you guys see that? That can get extremely confusing. So what I have my kids do, what Ms. Carver has her kids do, there's a little thing that a little shortcut you can use. Not really a shortcut, I just think it makes more sense. Pick a number, any number in the world, bigger than 1. 2. You could do 2 every single time. You could do 5 every time, whatever. I'm going to say 2. And what is the exact opposite of 2? Negative 2, okay? Now, I'm going to evaluate the given function with any number bigger than 1 and its exact opposite. And I'm going to get 2 answers here, correct? If my function is odd, what do you think those 2 answers will be of each other? Opposites. Because in an odd function, your arrows are going in opposite directions. Does that make sense? So let's try this. If I plug in 2 here, I have 2 cubed minus 2. Well, what's 2 cubed? 8, and 8 minus 2 is? Yeah, I don't know why I wrote 4. Thank you. All right, now on the opposite side, I'm going to evaluate using negative 2. So I have negative 2 cubed minus a negative 2, correct? What's negative 2 cubed? Negative 8 plus 2 gives me negative 6. Are those 2 numbers exact opposites of each other? So your function is odd. You guys just proved that. Now, you are welcome to plug in a negative x for every single equation and then be like, okay, did I plug it in and they came out exactly the same? Then they're even. If they came out exact opposites, but guys, when you have more than 1 or 2 x's in an equation, sometimes that can be really hard. So if I were you, algebraically, when you're doing these, I would pick any number. If you guys did this right now, and again, it's not a matter that you guys got 6 and negative 6. Somebody said 5 a second ago, right? Okay, so let's do 5 and negative 5. So 5 and negative 5. 5 cubed minus 5 and negative 5 cubed minus negative 5. Well, what's 5 cubed? 125? Minus 5 gives me 120. Agreed? Okay, so this becomes negative 125 plus 5 gives me what? Negative 120. Does the actual number 120, negative 120 matter? No. It's the relationship between the two. Are those 2 exact opposites of each other? Yeah, so you just proved that these are odd functions. Any number will work. If you came out, hold on one sec. Say you, well, no, go ahead, Maria, what's your question?
No, I was just gonna ask if you could do an example of neither.
Yeah, sure. Do we have another one? All right, let's throw it here. Well, I think I do have a neither in here. But look, if a function is even, guys, if it's even, I think I do have some examples at the end. It'll show you. If a function is even, that means the arrows go in the same direction. It gets cut in half by the y-axis, but your answers should be what of each other? The same. So again, if I plugged in negative x here, right? I'm trying to get this to be the same. If I plugged in negative x, what's negative x squared? X squared plus 1. Is that the same as what we started off with? Yes. But again, that can be confusing when the expressions and the equations get bigger. So let's just pick any number. Let's pick 3 this time. And this is how it's a good way to set it up and show me. 3 and negative 3. It doesn't matter which side you do the negative, which side you do the positive. But you're going to get 2 answers. And if a function is even, the answers will be the same. So I write the word same in the middle to remind me. Now, why am I assuming that this could be an even function? What's the highest exponent you see? A 2. What kind of a number is 2? It's even, so it's either going to be even or neither. Cannot be an odd function if the highest exponent is even. So if we plug in here, I'm going to plug in 3. So I have 3 squared plus 1. 3 squared is 9. 9 plus 1 is 10. Now I'm going to plug in negative 3. Negative 3 squared plus 1. Negative 3 squared is 9, and 9 plus 1 is 10. Are those 2 the same? So your function is even. And that is all I need to see. That basic math right there is all I need to see so that you guys proved that this function is even. I have some more examples at the end. I'll show you some that work out to be neither. All right, let's look at graphically. You guys are going to say, can we have like 15 of these on a test? Probably not. If you have a picture and it says, hey, is this even, odd, or neither? All right, you got to look at the ends of the graph. First of all, look at this first example. What are the direction of the arrows? Opposite, good. Does it go through the origin? So then this function is what? Odd. Opposite, odd. Look at the ends of this function. Are they both going in the same direction? Yes. Does the y-axis cut it in half perfectly? So then this function is even. It has to do both things. If both the arrows are going in the same direction, but the y doesn't cut it in half, then it's neither. If arrows are going in opposite directions, but the graph does not pass through the origin, then it's neither. That's super basic. All right, let's do some examples and we're done. Let's do the graphs at the bottom. Now, guys, pretend I drew this absolutely the best thing you've ever seen in your whole life, right? So let's check. Look at the directions of the arrows. Opposite or the same? Same. So what are my two possibilities here? This could be what or what? Even or neither. So, pretending that this is perfect, does the y-axis cut it in half? Yes, so this is an even function. Good. Directions of these arrows, same or opposite? Opposite. So what are my two options? Odd or neither. So what has to happen in order for this to be an odd function?
Origin.
Did it go through the origin?
No.
So this is neither. Yeah. Direction of the arrows. Opposite. Does it go through the origin?
Yeah.
So this is an odd function. Good. You may have a question like that on a test. That's a gimme if you guys get that wrong. I might cry. Oh, guess what? I totally forgot to record that whole thing. Okay, odd, even, either. I just went through this and didn't record. If you guys notice, in number 6, the arrows are going in the same direction, and the y-axis cuts it in half. It's symmetric to the y, that's why it's even. Number 7, the arrows are going in opposite directions, but it does not pass through the origin. That's why it's neither. And in number 8, opposite directions of the arrows, and it does pass through the origin. That's why it's odd. Let's do some algebraic examples, all right? This is how I expect to see, sure. This is how I expect to see on like your classwork tomorrow and on your test. But you guys will see this is not a difficult thing if you just follow these little teeny tiny steps. First of all, I'm going to identify the biggest exponent. What's the biggest exponent you see? A 3. What kind of a number is 3, odd or even? So my two options are either odd or neither, correct? Pick a number, any number. I'm going to do 2 and negative 2. 2 and negative 2. If this function is odd, what should these answers be of each other? They should be opposite. So now we just do a little basic math here. We say, okay, I have 2 cubed minus 6 times 2. Well, 2 cubed is 8 minus 12. What's 8 minus 12? Negative 4. Good. So over here, I have negative 2 cubed minus 6 times negative 2. What's negative 2 cubed?
8.
Negative 8 plus 12. What's negative 8 plus 12?
4.
Positive 4. Negative 4 is the opposite, exact opposite of positive 4, yes? So this function is, there you go. What about if I came out with 4 and 4? Would you guys say, oh wait, it must be even? No, what are the only possibilities for this? Odd or neither. So if it came out that they were both the same answer, then you would be like, oh nope, they're not opposites of each other. That's why I always say at the beginning, go here, just because coincidentally it would work out that they were both the same. If you're not looking for them to be the same, then you let it go. All right, number 2. Highest exponent you see is a 4. Don't worry about that 3. The The highest exponent I see is a 4. So my two options are either even or neither, correct? All right, let's stick with 2. I'll do a different number in a minute, but I don't feel like cubing big numbers. All right, so I have 2 to the 4th power minus 2 times 2 to the 3rd power. What's 2 to the 4th? 16 minus 2 times 8. 16 minus 16, and I get what? 0. Over here, I have negative 2 to the 4th minus 2 times negative 2 cubed. So negative 2 to the 4th is 16 minus 2 times negative 8. Yep. Yes? All right, so I have 16 plus 16, and I get what? 32. Now, could you have gotten here and gone, oh yeah, it's even because 16 minus 16 is 0? Yes, right? Pay attention to your signs. But I didn't write at the beginning what these should be of each other. I think it's a very important thing that you guys identify. If I think this is an even function, I'm going to write the word same in the middle. If I think it's an odd function, I'm going to write the word odd. So then you don't have to go back and think, what was I looking for? What was it? Are those two numbers the same? No. So my function is what? Neither. If you used a different number to evaluate, you would have gotten two different numbers. You wouldn't have gotten 0 and 32, but you would have gotten two different numbers. Does that make sense, guys? All right. Sure. Sure. All right, highest exponent. 2. So I think this either could be even or neither. I'm going to use 3 and negative 3. Don't ever use 1, guys. It doesn't always work. If I think this is an even function, what should they be of each other? The same. Okay, good. So I have 3 squared plus 2 times 3 plus 1. 3 squared is 9. 9 plus 6 plus 1. What's 9 plus 6? 15 plus 1 is 16. Good. So then here I have negative 3 squared plus 2 times negative 3 plus 1. Negative 3 squared is 9. 9 minus 6 plus 1. What's 9 minus 6? Plus 1 is, are those the same? So your answer is neither. That answer your question, Maria?
Yes.
Okay.
Thank you.
Yeah, sure. All right, what are my options here for 4? Highest exponent is a 2. It's either even or neither. Good. Let's do 5 and negative 5. Again, you can do whatever you want. I'm just picking different numbers so you guys see. If I think these are even, what would they be of each other? Same. Good. So 5 squared plus 6. 25 plus 6 is 31. Okay. Negative 5 squared plus 6. 25 plus 6 is? You guys just proved that these are even. Now again, you are welcome to plug in negative x. I just think in a problem like number 3, plugging in a negative x can get you guys confused. Last one, and then we're done. Highest exponent. It's a 3. So what are my two options for this one? Odd or neither. Good. So 2, negative 2. If I think this function, or if I prove that this function is odd, what would the answers be of each other? They would be opposite of each other. Good. Exact opposites. So again, careful with parentheses and stuff. So I have 2 times 2 cubed plus 7. We evaluate our exponents first. So 2 cubed is 8. 8 times 2 is 16 plus 7. What's 16 plus 7? What is it? 23? All right, so then I have 2 times negative 2 cubed plus 7. This would be negative 8 here, right? 2 times negative 8 is negative 16 plus 7. negative 9. Are those two opposites of each other? So you just proved this was neither. Now, some of you say, well, once I get here, I could see that it's not the same. I want you to follow through to the end to show me this step here, because then you actually are understanding, hey, those two are not opposites of each other. I'm proving that they are odd functions, or not odd functions. Excuse me, not odd functions. Questions? Okay.